Good evening, everybody. Welcome to the show. Welcome to the League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Friday night. It's April 19th, 2024. Welcome to the show. It's open lines tonight. Live chat is open. So if you have any questions, comments about the show or topics or whatever you want to talk about, please feel free and type stuff in the live chat. Hopefully, we'll have a couple of our usual guests pop in. I have all the links in the live chat for the StreamYard link. If you have a microphone, mic, webcam, you're good to go. You can click on the link. You'll go into the backstage area, and I'll let you into the show. So, yeah, this week been pretty busy. I've been doing a lot of job hunting. As you know, I've been laid off since January. So I've been doing a lot of that and also been doing a lot of experimentation with my batteries and the Renegade device. And I've also dabbled with the Gerard Morin device again. So everybody, I've changed my headset and mic. So please let me know in the live chat if my volume is good, just to let me know how things are. Yeah, this week I managed to meet up with Mr. B, my buddy there, and he got me this little jar of barium titanate. It's the powder for piezoelectrics. So he got me the powder. So I'll be doing a new batch of the batteries using the barium titanate. That's it there. And this little tiny bottle costs $28 US on eBay. So it costs like over $50 by the time shipping and all that kind of stuff happens. But this is going to be another element that's going to be added to those batteries. So I'm very curious to see if it's going to help. Okay, thanks, M4. Yep. I was hoping that my mic would be a lot better than what it was in the past. So that's good. That's a good sign. Now you guys can actually hear what I'm saying. So yeah, live chat is open. I got the links for the StreamYard. Any of my regular guests, Mike from Florida, if you're there, log in anytime you want. The links are there. Philip, if you're tuning into, I sent out the invites, and yeah, we can get the show on the road. And yeah, so going back to this one here is 99.9% barium titanate. It's the atomic number is BA, or capital B, small a, capital T, small I, large O to the power of 3. So that's the barium titanate. I can get it focused on my camera here better. That's it there. So yeah, I'm going to be throwing that into the battery mix this week and do a new batch of batteries and do some testing. So anyways, the batteries I have, I hooked it up to the oscillator. I actually have the video there in my video section at the Faraday Research webpage. And you can check out that video. I made the oscillator for the batteries. And these batteries have been running for 3 days straight now. And they're still pumping out power. I'm actually using a 9-volt battery to actually run the frequency generator. And those batteries are burning out. And my other battery that I made is just trucking along. It keeps pumping power out. It's pulsating. So yeah, it's turning out really, really good. But now I got this, my barium titanate. I'm going to add that to my composition of the battery. So yeah, the battery composition is the PEG material. You find it in a laxative. It's polyethylene glycol 3350. And a little bit of manganese dioxide, some sodium bicarbonate or like table salt. Mike, if you're yeah, hey Mike, how's it going? Jump on if you want. Yeah, I got the links there in the live chat for the StreamYard, so you can hop on whenever you're ready. Yeah, so that and the anode is the graphite, carbon graphite plate. And then the cathode, I'm using aluminum, and then on the back of the aluminum, I'm putting strips of magnesium. Now, because it's a dry cell, that magnesium now is deteriorating at a very, very slow rate. If it was wet, then it would oxidize and deteriorate a lot faster. But because it's a dry cell, that magnesium is actually helping out. Now it's slowed down the oxidation process, so they're lasting longer. Eventually, they will wear out, and you'll have to replace the uh, magnesium in it. But excuse me, overall, the battery performance is so far exceeding what I thought would happen. Now that I got the oscillation circuit hooked up to it, so yeah, really cool stuff. What else? Oh yeah, one thing that just kind of I found out tonight. I've been trying to get. Um, there's Mikey. I'm trying to get a plasma tube, and for the longest time, I haven't been able to outsource a plasma tube. Hey, Mikey,
It's all good.
how's it going? So yeah, I was just telling everybody I managed to find a plasma tube now. For the longest time, they weren't available. You can't get them, and now they're selling them on Amazon. I found one for $99. So there's some Don Smith devices that he made using that tube. I've done some work with the plasma globe, but the tube is better because you can add plates like capacitor plates going all the way down the shaft of it. So yeah, that might be one thing I might be getting in the near future is that plasma column. So I'll be able to do some more Don Smith stuff. So yeah. Oh yeah. I don't know if you saw it, Mike. I got the barium titanate powder. So yeah, this small bottle here costs twenty
Yeah, I
eight
saw that.
dollars. Yeah.
You gonna
So
make
I
a
picked.
battery out of that?
Yeah, I'm gonna add that to my composition. Yep. So I'm gonna make a new batch of batteries next week. So yeah, I got an oscillation circuit hooked up to the batteries, and they've been running for 3 days straight. Yeah, batteries have been pumping out power for over 3 days now. So you've been doing some work. I see you built your circuit, and I've seen some of your videos there. You're doing some testing, and you're using the Arduino for the cap dump, right?
Yeah.
Yeah. Oh, I meant to ask you. Can you hear me better now?
Yeah, much better. Great,
Yeah,
great job on the headset there.
yeah. I spent a whole $20 on a new headset. yeah,
Yeah, that's how much mine were.
yeah, 20
Twinsies,
bucks.
right?
Hey, can't go wrong. Went to Staples and picked up a pair of headphones for $20. But as long as they work and people can hear me a lot better, that's the main thing, right? So yeah. So maybe you want to here. Let me get you. Oh no, not that one. Trying to figure out which one's which. Uh, Solo. Okay. Okay, I got you on there. All right, man. The floor is yours.
I mean, I have questions actually more than answers. Um,
Live chat's open, everybody. So if you have questions for Mike or myself, um, yeah, you can do so. Yeah, let's kind of explain what you got going on there, so everybody can kind of follow you.
um, well, the battery's unplugged right now.
Yeah.
What I think is going on is there's about 2 or 3 volts in here.
Right. Yeah, it recharges. We were talking about that a while ago. How those caps, when you think they're actually empty, they're actually restoring power because there's residual charge on the plates inside the capacitor. So it's gonna throw back some power in there, even though that you thought it was drained out.
Oh, it's weird. but there's a couple volts in there, right?
Yeah.
And it's powering the inductor, this one, with power,
Yeah.
not the battery. The battery's
Right.
not giving any power here. This is,
Right.
and this is just, the battery is just getting the flyback.
Right.
Um,
Is that the only load you have in the circuit, or
yeah, it's a 350 ohm coil, so it's like 34 milliamps on 12 volts. I already
right?
did the math on that.
Right.
It's nothing, so
Okay. So
it's
you
good
got
for testing.
so you got the Arduino there. That's hooked up. That's controlling the dump for the capacitors, correct?
Right, the red LED is the,
Right.
can you
So
see it over there?
what kind of timing sequence do you have on this right now?
You can see it flashing. Let me move this.
So it's what, every 2 or 3 seconds it
See the
dumps.
red and the blue LED?
Right. Yeah. Oh, okay.
Okay, yeah.
So now it's charging.
So the blue LED is the frequency of the trigger on this.
Okay.
So the blue LED is controlling one of these transistors. It's triggering the negative of
R-
the battery
Right.
to 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 hit the trigger negative on the relay.
Yeah.
The positive on the relay trigger is jumped to the battery,
Right.
but the battery's disconnected right now. So how is it getting power to trigger? I'm going to answer that right now. I just figured it out online here. This capacitor
Yeah.
is storing power.
Right.
These bottom two pins here on the relay is the bus power, the plus and minus.
Right.
That's the plus and minus that ends up in the coil eventually.
Right.
Okay.
So
But the
now,
relay flips the plus and minus each flip. It flips the
now,
poles
now
hitting
is
the coil.
that capacitor there getting any back EMF, or is it
Okay,
being
that's what I'm going to tell you right now. Check this out.
ah,
This capacitor bank with the 2 or 3 volts that it's holding in there,
right?
still draining,
Hmm.
to the 350 ohm coil and this relay. Somehow the flyback, well, yeah, the flyback is wired to hit here anyway,
Right.
and it's also wired to hit the battery. So if the battery's not connected, this will be still connected. The capacitor,
Right.
this is a 450 volt high
Right.
frequency capacitor.
Right.
So it's holding some power,
Yeah.
and it's giving this here a negative to the capacitor bank again. But oh god,
Yeah.
I
You're
think what's
just
going on is the flyback is the flyback coming out, the forward pulse coming into the coil,
yep.
flying back into this capacitor only because the battery's not hooked up right now.
Right.
And the capacitor and the battery are parallel.
Okay.
So that's what's going on, and that's why it's still triggering this relay, although you can't hear it right now because the voltage is even lower than it was earlier.
Right. Now, is there an actual cutoff point, like before it doesn't work at all?
It seems to be triggering it still because I don't get why.
Yeah. There's got to be some residual power.
Okay, here. Okay, look. Let me explain how this meter's hooked up. You see the extension cord here?
Yeah. Okay.
That's the ground. You see that drill bit?
Okay.
It's stuck in the ground port of the extension cord.
Okay.
So this is earth ground.
Okay.
And this the negative of the meter is hooked up to earth ground.
Okay.
Just that's it. That's the only thing that the negative of the meter is touching is the earth ground.
Right.
Nothing else. And only the positive is touching this pickup coil inside there. It's
Yeah.
500 feet of 23 gauge,
I
15
think
ohms.
there's one thing that we can't rule out in
I don't
this device.
understand. Look, why is the
Well,
voltage up
yeah,
more?
well, okay, just let me
The
explain.
battery's disconnected.
Right. Now, let me explain what's going on. Because a lot of people don't take this into consideration when you're working with capacitors, is the heavy side component, is the electrostatic charge that's accumulated on the plates inside the
Unplug the
capacitors.
oscillator.
It'll still have power in it. Doesn't matter. if you shut it
Right. Well,
off.
now that it's not oscillating, but it's
Right,
holding one side closed. So this is getting 34 milliamps continuous now
right.
because it's a
So now,
double pole relay.
right. So now it's going to
So that's the
drain.
drop
Right.
on the.
Second you turn it back on, the oscillation starts, and then it starts collecting back EMF charge or the heavy side component, and
Yes.
keeping those capacitors with electrostatic charge. And I'm even finding that same kind of scenario with these batteries I'm working on. I feel that there is an electrostatic component to these batteries. Um,
So the battery's disconnected. I'm going to measure
if you were to leave,
capacitor bank right now.
if you were
Stick
to
it.
leave it, if you were to leave it like this and leave it say for 24 hours, you might be surprised. It might actually even charge them capacitors even more. Just for kicks and giggles, after the show tonight, leave it on the way you got it, and just leave it
So
for
look,
20.
capacitor is down to 1.3 volts.
Yeah,
Capacitor bank.
and it's still working. Now,
It's
just
still oscillating. You can't feel it because it's such a
yeah,
low.
yeah,
You
but
know.
just let it sit and see if it starts gaining the power back. I have a feeling it will.
No, it's dropping slowly because there's resistors in this capacitor bank.
Oh, okay.
Yeah, balancing resistors. So let's.
Yeah. Okay.
I'm gonna do away with this and go with
Yeah,
straight.
get rid of the balance board. The balance board's designed to actually
I
discharge the
know, I know.
capacitor.
I'll
Yeah,
realize that later.
I've
But that's
got
still
one.
good enough for testing. And
Sure.
so watch the. I'm gonna show the capacitor bank charge up here. Let's
Everybody, the
plug it
live
in.
chat's open. If you have questions for Mike, please type in the live
You hear
chat.
it buzzing? There's the. Okay.
So you got the battery hooked up now?
Yeah, and it's charging the capacitor with the red LED. Let me use the compass.
Yeah, that's kind of cool. You were able to get the Arduino set up for the cap dumping. That can come in pretty handy for some devices.
Yeah, that that took me a long time to find that code. It's just a starter code or whatever. And
Yeah,
it makes it so that each pin has a separate triggering revolution,
yeah,
and you don't have to wait for them to go in sequence.
yeah.
Um, well,
Either way,
um,
you know what? It's very related to. There's many similarities of many different devices with different names, but when it comes down to it, it's doing the same thing. It's oscillation circuit, so you got your jewel thief circuit, same deal. It's just a bunch of different devices with different names, but in essence, it's all the same, right? You're just using a different method of oscillation and coil setup and whatever, but it's still doing the same effect, right?
flyback. Right. That's the
Yeah.
battery voltage. It's dropping. It was at 13 point, 2 or something. It's
Yeah,
going into
but
here
the
now.
yeah, but the standing voltage on those batteries, Mike, is usually about 12.6 to 12.7 volts. So you could charge it up to say 13 or even 14 volts,
Yeah,
but the,
yeah.
the second you shut it off, it's going to go back to
That's the
12.6.
capacitor voltage.
Yeah,
You see a slow rise. As the
yeah,
red LED lights up, you'll see it bump up.
yeah. But like I was saying, those the battery
See how it's
voltage,
dropping when the LED's off? And now it bumps up when the LED's on.
right? Yeah, yeah.
And,
Turn the light.
the whole time the flyback is sitting here, the battery, just pure flyback.
Yeah, know
Whatever
what I would.
flyback.
If you have a good 12-volt light, hook it up to the battery and drain the battery down a bit. Drain it down to say like 12 volts or just under 12 volts, and
Well,
then
it's being
start.
drained by the capacitor bank now. Once the capacitor bank's full, the battery
Yeah,
comes back up,
yeah,
and they kind of stay close to each other on voltage.
yeah. Try to pull the battery down. Just if you want to do a really good test, pull it down to like 12 volts or just under, and
Yeah.
then start up the circuit again and see how fast it charges it
What I
up.
like about this though is I can drain the battery into
Mhm.
the capacitor bank and refill it back up with flyback
Yeah, exactly. Yep.
with this cycle here.
Yeah.
It'll come out the battery into the capacitor bank, turn that into flyback, and put it back into the battery as flyback.
Yeah. Yeah. That's very
And
cool.
yeah. So
So you
that's the
finally.
voltage on the capacitor bank. I'll unplug the battery.
Yeah. Hopefully.
And
Hopefully Gerald can join us tonight. I sent all the invites out. I don't know. Sometimes
see,
people. Yeah. Yeah. It's good. Yeah. That's really cool. Yeah.
hmm.
Nice little setup, and it doesn't seem to be very complicated. As soon as you get the electronics and the, are you going to eventually put that circuit on a perf board or?
I'm getting 48 volts on here on the positive flyback output of the diodes.
Yeah. Yeah, that's good.
From here to ground, sorry.
Yeah.
Earth ground. I get
Yeah.
45 volts.
Yep. Oh,
Can't you hook up the load in a one wire system to ground like that and just
yeah. Yeah. That's what I did
take
with the
those 45 volts and drop them down to turn it into a current?
Yeah, like as soon as you get into the capacitor, then you could put it through a PWM, and you could do it like that, run motors, or hook it up to an oscillator and step it up using a step up transformer, or step it down to get more current. You can do it either way. It's a matter of how what the frequency of the actual flyback is. So um, uh, Philip is saying something
I
here.
don't know what the actual frequency is. What do we got? Gotta be on AC. See, look, AC, 45 volts
Yeah, that's cool.
on the positive output of the positive flyback, not the negative flyback. Now, I'm sure I could check the negative flyback right now. And this
Mhm,
is 45 volts off the 3 volts that are in the capacitor bank.
mhm.
That's the negative flyback, also 45 volts.
Yep.
It's not showing positive or negative. They both showing the same.
How heavy is that coil, would you say, in weight?
The load coil is gauge 28, 5,000 feet. It's like 2.5 pounds. Sorry,
Yeah,
exactly 2.5 pounds.
that's why you're getting that. What gauge
So
wire, sorry?
anyway, this positive of the meter
What's
is
the gauge wire?
touching the
What's the
flyback output here to get
what's the
that
gauge
45 volts.
what's the gauge wire again? Sorry,
28, 2.5
28
pounds.
gauge. Wow, that's a lot.
And the negative is hooked to ground.
Yeah. Yep.
The
Yep.
positive of the meter is touching the flyback to get you those 45 volts. And that's with a 3-volt supply. What's in the
Yeah.
capacitor bank is 3 volts. If
Yeah.
I hook up the battery here and leave it hooked up long enough to charge this up to 12 or 13 volts, capacitor bank, then I assume the flyback would be around 80 volts or something.
Yeah.
100.
Oh yeah. Probably more. I was able to get the Renegade up to 126.5 volts now with the and Mike the coil and the coil I'm using is only 1 pound.
Just
So
yeah, I mean, if you can make any sense of what I just showed you there,
no, it's showing it's very much like a jewel thief in a lot of ways.
so it's just stepping up voltage.
Yeah, it's stepping it up, and the back EMF is coming back, charging The capacitors are the battery, and then you're controlling it with the Arduino back and forth. Yeah, it's very much a kind of a hybrid version of the Joule Thief circuit, right? Like I said, all these devices are so like they're different setups. There's so many different combinations, but in essence, it's doing exactly the same thing. Yeah. Oh, Philip just texted me. He's going to be here in about 5 minutes.
So you
He
see the
was,
pickup coil? It's getting 4 volts.
yeah,
That's the pickup. That's just a stator coil inside here. That's
yeah,
the
yeah,
500 feet of gauge 23. And just one end of it, touching one end, I
yeah,
get 4 volts. Either end, same thing. I
yeah,
don't understand that. I guess you rectify one end or the other with diode, and that's how you get your DC. So it's AC, I
yeah,
guess, right now. It's AC, so
yeah.
that's why it's showing
Well,
4 volts on both ends.
it's a hybrid,
So
right?
that's 4 volts
Because
peak to peak. I guess it's 8 volts then.
see, it's kind of a unique type of power that we're dealing with. It's not AC and it's not DC.
Well, it is
It-
because
no,
it's the
no.
poles are flipping. So like this side here becomes a north, then a south, north, then south.
Well, what I'm trying to
Same
say
thing on
is
the
like
other side.
what I'm trying to say is because it's a DC and the way we're pulsating it, that's why you can run a DC motor with it and also run an incandescent light bulb. It can't actually tell what it is. It's like a hybrid of the two, right? DC and AC. So,
Right.
but the cool part about it is because we're doing it like this and that type of energy that we're playing with, it doesn't wreck electronics. It won't wreck a light bulb and it won't wreck any other electronic component as long as it's at the proper voltages, right? And current. But it's cold electricity. Like the Gerard Morin device, when I spin the pump up, when I spin that pump, I can put my fingers on the high voltage leads and I don't get electrocuted. I'm not getting shocked. But it's putting out 35 watts of power. Like I can lick my fingers, and, I could. Um, let's get back here. Get the proper layout going here. Sorry, my computer is acting up. There we go. I got it. Yeah. So because it's a pulse DC, the components that we're hooking up to a load, either incandescent light bulb or to a battery or whatever. That's why, because like if you were to pump regular AC from the wall into a battery, you blow the crap out of it. But if you're doing a pulse DC, you can put in an AC light bulb or incandescent, doesn't hurt it, and you can pump it into a battery and it doesn't hurt it. It's like a hybrid. It's not the same.
Right, right. It's just it's not doesn't have a wide signal. Narrow.
It's a interesting, really interesting type of um, type of wave. Um,
Like the 3-phase AC signal has a long duty cycle. That gives it all the amperage, but it's a lower voltage, much lower voltage.
yeah, like originally Tesla when he designed the AC motor, it was actually 4-phase, and that's what originally he wanted was a 4-phase circuit. But by the time they started doing all the power distribution, they went to the um, they went to the 3-phase circuits, and yeah, so even Eric Dollar did a whole lecture on the quad phase circuit, and it was pretty interesting. Yeah. Any other thing you wanted to share, or guys? The live chat is open. See if we
I'm
got a
just
comment.
trying to figure out how to
Oh,
tap off that 45 volts.
Lulu's in the house. Hi, Lulu. If you want to join the show, you can hop on.
Yeah, Lulu. Well, you can definitely you can increase your efficiency with the pulse circuits.
Yeah, you're utilizing three channels of power at the same time. Same with the quad phase. Now, the quad phase and the three phase, they're used in industry, right? Running big motors and machinery and stuff like that. You need those extra channels of power. Like in a regular house, that everybody lives in, they got a single phase system, 120 volts at 100 amps. Most houses are 100 amps. You can't get it up to 200 amps, but in Canada, this is what they did in Canada. If you want a 200 amp service, right? Well, instead of basically adding more current to the 120-volt phase, they will pull from the street another 120-volt line and merge it together at the box at your house. So it's basically you got a two-phase system, 120 volts at 100 amps each. So instead of doing it on one line, they split it into two lines and merge it as one when it hits your box in your house, which is kind of funny, but that's the way they do it here anyway. I don't know what they do in the US, but that's how they do it here.
You mean
Because
your 240 leg?
no, no, your um, 200 amp service, because most homes are 100 amps. So if you want to go to a 200 amp, instead of doing one line with 200 amps, they'll pull another 120 in to make a 240 at your box, and then they split it. So that's how they
240.
do it.
That's two poles to 240. Here we have single pole 240.
Yeah, see, we don't have that. They pull two
Yeah,
120.
that's the three phase here. The three phase here is you have three
No,
poles
no,
coming
no.
in the
I
panel.
Oh, yeah, actually, at your house, because we only have
No,
two.
not residential, commercial, industrial. They have three phase
No,
panels.
no, no, no. I was still referring to residential because some people want
Residential
to.
is just two phases. Just two 110s or 120
Yeah,
volts lines.
yeah. Oh, okay. So it's the same. So they do that here too. Yeah,
Yeah. But if you
yeah.
go to commercial, it's then the third phase is 240 volt, one leg,
N-
one wire, holding
Right.
that voltage.
And the cable's like this big.
It's the same size cable as the other two, just higher voltage,
Yeah,
and it's only one wire instead of two, and they just use that so that you can run single phase 240 devices. If you have to run something that's 480,
yeah,
you have two phases of 120 and another phase of 240, and that gives
yeah.
you 480.
Hmm.
Or yeah, 480. So then I don't know. There are devices that use 480 volts.
Yeah, it's usually the heavy machinery. Like I know for the CNC machines that I used to work on, they run on 480 volts at
Mm.
I think it's well, some of the smaller ones is only 80 amps. Some of the other ones go up to 150 to 200 amps. The bigger
So how do you
machines.
suppose this is flyback thing is different than the three phase power? So you can definitely channel the high voltage and whatever little bit of current that's behind it through any
See,
line you want.
see. The thing is, what's great about this power that you have is you can manipulate the frequency to whatever you want. Where the stuff that comes through your house, it's fixed, right? So
Right.
with the power that we're working with, we can pretty much do whatever the heck we want with it. You know, we could change, add as many phases we want. We could up the voltage, down the voltage. We have full control. Where anything from the power company, what they give you is what you get. That's it, right?
Yeah.
So yeah, it's pretty interesting. Yeah, and don't forget the power we're working with is cold electricity. Back EMF is negative energy, right?
I think the best
So
way to capture that energy is with a magnet and a shaft or a rotor.
Yeah, induction. Yeah, it really does well with induction, but the only problem is with induction is, anytime you get a magnetic field, there's always going to be losses. There will always be mechanical.
Oh, you have to. If you have an inductor, you are going to have a magnetic field no matter what.
Right, right. But there's always, because you're creating magnetic field with an inductor, there's always be losses.
That's the idea behind the stator, though, to capture those losses.
Yeah, yeah. It's a lot of it has to do with coil design. You could do bifilar, to try to
You
capture.
suppose the iron core will help focus everything around the stator?
From what I've heard, iron is probably one of the worst things to use because it is, when you energize a magnetic field in with iron present, when you shut that magnetic field off, um, basically what will happen is the iron becomes magnetized. It doesn't lose its magnetism.
Oh,
So
right,
if you're using it for a motor, now you're going to get cogging, right? So
right.
you want a soft metal with very little carbon in it. Actually, if you use birdshot, I forget what number it is, number 7 birdshot. It's a really soft steel, and Paul Babcock had a method of making cores using these little pellets that you would use for hunting.
So long
And
as you can keep that magnetic field from sticking around, you're fine,
well,
right?
yeah, see, it has to be like a switch. Turn it on, you got magnetism. You shut it off, the magnetism disappears right away.
You
It
get rid
doesn't
of the
hit.
carbon in the steel, and you can do that.
Yes, and that's why the number 7 birdshot is very good because the type of metal it is. It's a very soft steel.
All right, look,
Very.
regardless, if you get rid of the carbon and you have a core, do you think it's better to have a core than not have a core?
I don't know. There's
I
a lot
mean,
of guys
especially
that
if you got stators involved, you're trying to capture that EMF, not lose it.
it helps increase the induction, right, over an air core.
So
You
would
won't.
you say it helps it capture the EMF, or it help, or it
Oh yeah.
worsens the
Oh
capture?
yeah. It helps. It's a double edged sword. It helps you capture the back EMF with the induction of the core, but
For the
it can
same
also.
token, the iron could also help you lose the EMF by capturing it.
Well, no, it stores it in the iron. Iron stores that magnetic field, right? And that's when you get the cogging, and that's what you don't want. So it's a double edged
So you can
sword.
get the iron to capture the EMF quickly, and then dump it into the coil from there.
Right, but that boils down to the type of material you're using for your inductor, right? It's trying to find that superior element that will basically make the magnetism disappear.
Into the coil.
That's right, and not in the core. If it stays in the core and keeps that core magnetized, now it's working against you. That's when you get the drag, the cogging of the motor, the
Right.
lens law. The lens law then just friggin' takes over, right?
From the iron keeping its magnetic field,
Yeah,
creates
yeah,
that. Right.
yeah, exactly. Hey, Philip, how's it going?
Hey, pretty good
Stuff
yourself.
to
So
do.
sorry, I'm a little bit late. I was away.
Oh, that's okay. No problem. Can
Uh,
you hear? Can you hear me better now?
yeah, I hear you. All right.
Yeah, I spent $20.
You sound like a air traffic control man.
Oh, do I? Well, at
Uh,
least you can hear me now.
yeah, I sent you a link on Telegram about free energy. It's pretty cool.
Oh yeah, yeah, yeah. I've seen that there. Yeah, I'll check it out after the show, or if you want to put it up and we can look at it.
Yeah, I'll share it with both of
So I
you.
have a stator coil in there. I'm going to build a soft iron core for it.
Now, another one that works okay. I have had pretty good luck with is use welding rods. The
Yeah,
softest
I got
welding
it.
rod. Yeah, so get those. Cut
I
them.
have the BB shot pellets already, so they're
Yeah.
easier
Oh,
to.
there you go. So all you got to do is spray those with a silicone spray,
Hmm.
like completely cover them with silicone spray, like individually. Put them
Insulate
in.
each one.
Yeah. So what you do is put them in a box, dump them all in there, take the silicone spray it. After it dries, shake them around, spray it again, shake it around, spray it again until all of them are completely individually covered. After that's done, then you put it into a core.
You know what I did once? I used epoxy spray paint to insulate each one.
Yeah, you could do that. Yeah, that worked perfect. Yep.
Yeah. So I was just going on a hunch there. Better to have each core insulated from the other core. That way you have multiple independent little cores, working together. So
Yeah, that's
but
cool.
the silicone spray, where do you get that? Where's that at Home Depot or?
Yeah, Home Depot, they sell it. Yeah, they usually sell it in the painting section. Sealants and stuff like that. Yeah, Home Depot will have it for sure.
So
Hey,
making the core will get that EMF into the coil better, more effectively.
yeah, yeah. Well, you got to isolate them so they don't, short themselves out with the field. But Paul Babcock's been doing it, and he says he gets the best results with using the birdshot.
Yeah. I have one Bedini motor with a VCR rotor.
Oh, the
VCR
VCR
head
motor.
rotor.
Oh, yeah. I've seen that device. That's really cool.
That core has the BB shot in there, and that's the only one that self-oscillates too.
Yep.
After running it for a few hours, it'll.
Yeah, actually, you don't even have to have the wheel
own.
spinning. It doesn't even have to spin. It'll
Yeah.
just start oscillating on its own.
It's the only one that did that actually made the core out of that material.
Yeah, that's the best material, man. So if you're going to make
The welding rods also did that. But when I had two cores close together,
yeah,
that's when they were oscillating each other.
right.
When they get close enough and you trigger one, the EMF off the one will reach over to the other one. If you got two bifilers,
yeah,
and two separate circuits,
mm-hmm.
You trigger one. If they're close enough, the field will reach over and trigger the other. And
right on.
They'll keep buzzing each other. They'll
yeah,
trigger each other.
Like it's like apples and oranges. Some guys like doing with the air core, and some guys prefer with the inductor. It's it's like some people are different, right? They want to work with the air core.
You mean an air core
yeah, exactly. Some people prefer using just an air core, right? My ideal inductor is actually, I talked about it before, is actually like a pipe. So the actual inside center of the core is hollow, and you just have the inductor going around the rim of the core. And Bedini was doing that just before he passed away. He did it with his zero force motor. So, yeah.
So a nice steel pipe, or
yeah, steel pipe. Yeah, I think it was a conduit pipe. Or I'm trying to think of what he was using. It was like just a steel conduit, I think, that you use for wiring. I think
by the way, now that you just said that, on this, what I'm noticing, the field is strongest on the inside of the donut.
Right. That's right. Well, no, on the outside rim. The
field is on the outside of the donut, of the perimeter,
right.
not the center of the donut.
Right.
But underneath the donut, underneath, it's even stronger.
Right.
On the inside of the donut, it seems like the field is pushing inwards.
Right.
So,
Philip, you have anything to share?
Actually, I had a question for you guys. I'm just curious. Just out of curiosity, I'm looking for a way to generate I'm not sure if I'm just daydreaming or something, but to generate the energy density of a neutron star, the equivalent energy density of a neutron star, which is around 8 times 32 joules per meter cubic per cubic meter.
That's a
Yeah,
huge amount of power.
yeah, it's pretty crazy, but I don't think it's possible. Though. I'm just wondering what's.
I don't think the nearest nuclear power plant can make that amount of power. That's a massive amount of power.
Sounds like TNT, man.
Yeah, even matter antimatter reaction won't be sufficient for that. So I think I'm gonna have to put that on the shelves. It was about I want yeah I want to generate like tractor beams and things like that, but you need that amount of energy. Would even with my own theory, um,
That's a lot of juice.
yeah, it's a lot of juice, but a lot less than what JR predicts. But I just thought it would be cool to have force fields and things like that. But I think you
Well,
need too much energy.
well, design yourself a black hole, and maybe you'll have enough power.
Yeah,
Well, and then they get to the point where you can't control the power.
but I'm
It's
just wondering also with your
tough,
free
possibly.
energy device, can you scale it up infinitely or?
You can scale up voltage, but with Ohm's law, when voltage goes up, current goes down, power goes down.
Yep, that's the way it goes. So that's why Tesla was working. Some of his coils were hitting about 4 million electron volts, but it didn't have the current. If you were to drop it down just a fraction, I heard some of his coils were pumping out 2,500 amps. Now that's a massive amount of current.
Extremely low voltage, and then you have trouble propelling that current because you got no force behind it, the voltage.
Yeah, it would be like a really difficult balancing act to get the right voltage with the right current to get the maximum output in watts, right?
Yeah.
Okay, if this is your coil, the field on the coil is strongest on the inside. It's strong on the outside too, but when you put it in the inside, it's twice as strong. So when you're pulsing the north this way, right, and the south that way, the north is going to go up, out the top, around the bottom, and up the bottom. So that explains why it's stronger on the inside, because the two fields are converging in the center of the donut, not on the outside. Right?
So
that
your
makes
zero,
sense to me.
Yeah, your 0 point is actually right in the center of that coil. That 0 point, there's no field there. That's where the 0 is.
The two fields meet in the middle right here.
Well, that's 0.
They come out the top. They come out the top. They go around the top, out around the side, up the bottom, and meet in the middle. So that's why I'm feeling a stronger pulse on the inside and not the outside. Because the two fields meet in the middle, on the inside. That's just my rationale for that.
Yeah, Ken Wheeler
has. That's why I put the stator coil on the big coil. It's on the inside.
Yeah, the inside rim. Yeah, it's basically the rim of the magnet is where the magnetism is. Right at the center of that magnet, it's actually there's no magnetic field at all.
If you had a shaft in the middle with a magnet in the middle, just like Newman did it, plenty of force there, in my opinion, to spin that magnet.
Okay.
Oh, by the way, I can't share the link publicly, but next Tuesday I'm gonna have a presentation with the five eyes government agencies like Canada, United States, UK, Australia, and New Zealand to present my technology. So that's pretty awesome. That's stress at all here.
Yeah, just have a couple of shots and you'll be fine.
Yeah, that's what I did. I was at the bar next door. So.
couple of nice shots of Jack Daniels or some vodka or mix them both or whatever.
Yeah, I'm gonna do. I mean, I think I better get a beard cut, huh? I look like a homeless guy right now.
Yeah, I got the scruff going too.
Phil, for that energy reserve, I mean, you could put it in batteries, but a flywheel would be more reliable.
Yeah, I heard about the
A flywheel
flywheel
connected
too.
to a
Yeah.
real-time generator.
Yeah, there was a company in Europe that was doing it, and apparently they went bankrupt. Just couldn't keep it going. Nobody wanted to invest in it. And meanwhile, they had, their storage system was incredible. Apparently, they had like 5 or 6 silos with these huge masses spinning, and whenever you needed current, it would just take it, right? Because they had so much energy in those spinning masses. But even the Formula One racing, if you take a look into some of their technology they've been working on the last couple of years, uh, they're using them in their engines for extreme acceleration out of a corner. They engage the flywheel to the axle coming out of
So
a
they don't
turn.
flip over.
No acceleration. It gives the engine like twice the amount of acceleration coming out of a corner.
Oh, nice.
Like, yeah, they're freaking rockets on wheels. These things are ridiculously fast. If they had wings, they would fly.
Yeah,
So
that's
What do
interesting.
you mean they're hitting the neutral on the turn?
normally they downshift going into the corner. So right when they got high RPM, just prior to entering the corner, they detach the flywheel from the drive shaft. So now
They
the
hit the
flywheel,
neutral. They hit the neutral.
so the flywheel's still
Clutch,
spinning
sorry.
at
Oh,
full
sorry, the
speed.
clutch.
They hit the clutch. The flywheel keeps spinning at the high end speed, like say 10,000 RPM.
Right.
After they put on the clutch, they downshift, they go into the corner, and just as they're coming out of the corner, they re-engage the flywheel. The flywheel's already spinning at 10,000 RPM, and they just take off. They take off like a slingshot coming out of the corner. So yeah, F1's been working on that technology. Yeah. So
on that relay, I realized that I could put a switch to convert it into instead of a AC, north south, I can convert it into a north by just putting a switch in one location
yeah.
and disconnecting one of the
Or
legs.
just after the capacitor, you could hook it up to a frequency generator and do whatever the heck you want with it, whatever frequency, whatever duty cycle you wish, and then you could even dump that into another inductor and get another flyback again. You could constantly stepping it up in
I'm gonna
stages.
put that switch there so I can experiment between having I don't know what you call it when you flip the poles. What do you call that?
It's when you flip the
AC?
pole,
I call it AC.
well, it's bipolar, I guess, wouldn't it?
Yeah, well, I'm gonna call it AC for now. And when you don't flip the poles and you just hit a north, or
Well, see,
south,
normally,
that's DC.
normally when you get a back EMF, right, the poles flip right away. So
No, I mean the double throw relay is flipping the poles on the inductor,
Yeah.
each pulse.
no, but
So one
when
side of the inductor is getting a north, on the next flip, that side is getting a south. So
but
it's flipping.
normally on a flyback, anyways, when you get a flyback, the poles flip on its own within the coil.
Right.
There's
But
already
now
a flip going
I'm
on.
causing the flyback to flip each time.
Yeah.
Because I'm not doing north. I'm doing north, south.
Right.
By flipping the poles on the double pole, double throw. So if
Yeah.
I disconnect one of the legs on that double pole, double throw on one side only,
hmm
next time it throws, it's only going to throw one polarity, not two.
Right.
So I can add a switch to it and do experiments now. And and quickly convert it over to a single polarity relay by adding one switch. I'll show you later in a video. I've already got it mapped out. I'm going to put one switch on there so I can switch from bipolar to single polar on just not with the same relay without changing the relay.
Yeah.
Just disconnecting one leg.
Right.
The,
yeah, you got to try all different configurations, whatever you can. That's what I've been doing this week with the friggin' Renegade. I've done so much testing on that. So it's crazy.
When that's done, I'll be able to see the difference between hitting it with a monopole or a pole flip.
Yeah. So, I don't know if I told you guys, I stripped down an old microwave oven. I got the transformer out of it. It's a 700 watt, and it actually worked with the Renegade. But I figured out all the experimentation I did last week. I don't even need it. I figured out how to do it without the microwave transformer. So I've simplified the circuit greatly, and I'm getting a consistent 126 volts coming out the other end. So that's really
helpful. With the transformer.
Well, I was trying to step it up. It does work. Right. I was getting about 110, and then I figured out this other circuit, and I was able to get 126.5 volts consistently. So yeah.
And before you hit the transformer, what was your voltage?
Before,
coming off the inductor, primary, I guess.
Well, it depends on the frequency. Like I get back EMF spikes hitting about 450 volts, but that's just high voltage. There's no current behind it. So when you step it right down, I was always hovering about 100 volts. So now I've got about another 26 volts added to that.
Because the microwave transformer is high voltage transformer.
Yeah, so but it requires, but it does require a certain amount of wattage to even run the damn thing, right? So, but still, I was still getting 110 volts out of it with the Renegade. So I figured out a simplified circuit that did the same thing, actually even better, more efficiently. And now I'm getting 126.5 volts. Actually,
Once you get your voltages that you want, wherever in and out, wherever you get your voltages, then you can step up. I mean, increase your frequency to get more current.
Yeah, you could dump that into an oscillation circuit, which I've actually built this week for the batteries. So my batteries have been running for 3 days straight. They've been running on an oscillator. So, and the other great part about it is, second I take the load off, the batteries go back up to full power. They just totally come back. So, Philip, I got my barium titanate in. My I got a bottle. It costs $28 US. It's 99% barium titanate. That's the atomic number for it. So I'm going to be adding that to the battery cell.
Okay.
Piezoelectric element.
Oh yeah, that's right. That's what it is.
Yeah. Yep. So this is the best material that I know of right now is the barium titanate. So this is the powdered form. So I'm going to add that to my battery mix and make a new set of batteries and see what happens.
That's going to catalyze the current, or?
I hope so.
Yeah.
Yep. So I got that. So I'm going to be redoing all the batteries next week. I'll strip the ones down that I made. I got to get some aluminum sheets from Home Depot and make the cathode with those. And
then make a battery that can create the energy density of a neutron star.
No pressure. No pressure.
If I were to go for that kind of amperage, I'm looking at, a train has wheels that are made out of iron. You get like 10 of those on a nice bearing. Get them spun up as fast as you can get them spun up, tie that to a huge ass generator, and maybe we're talking, that kind of energy. But you can't do it with batteries. You need a flywheel.
Yeah.
Like real-time spin.
Yeah, but you need the energy to make the wheel spin.
I think that's they
Well, the
did for
thing
the
is,
Philadelphia experiment. Didn't they have the generators and
well,
diesel?
no, they made a Faraday disc generator. What university? I think University
Yeah,
of
but they
Texas.
had real time spin going on to power that thing.
Yeah, that rotor there, I think, was 2.5 tons. So
There you
yeah, that
go.
was
That
that was
flywheel. It was a flywheel.
yeah. Oh yeah, two and a
Two
half
and a half
tons.
tons.
Yeah,
That's not easy to stop once it starts spinning. So when
you get
you could put
you.
a pretty big load on that.
Yeah, you get that spinning at 20,000 RPM. Yeah, you're not stopping that anytime soon.
Yeah. I think that kind of weight spinning at that kind of speed, you cross a threshold where if you were to put a load on there
It
at,
would
let's say,
absorb it.
an infinite load, it wouldn't, you're not going to affect it. It's just,
Yeah, there's too much
it's the
inertia
threshold.
going there. Yeah, there's
Yeah,
too
the
much
inertia.
inertia there. You got 2 tons, say, at
All right, let's just say the
20,000
stator coils
RPM.
will burn up and fly before that wheel stops spinning.
Oh yeah, you're gonna get some major heat in the inductors, man. You better have a good friggin' dummy load there, or the way to dump that extra current, because you'll vaporize the wires.
They'll melt.
Oh god, yeah. At that amount of power, if you're
I'm
pumping
thinking
like,
this type of stuff, tractor beams and all that stuff is really with resonance, not so much high current, but melodic tones and resonant, harmonic, you know, synchronous waveforms.
well, you see, he's looking for more like brute force power, right?
I don't think it works
Yeah,
like that.
I even look at the possibility of using solar panels in space, but they would need like billion meters long,
Yeah,
solar panels. So it's crazy. A trillion, sorry.
yeah.
So, but it's possible. But I mean, just
I
a
mean, Phil,
couple
when
of
you talk
zeros.
about energy, the cleaner the sine wave is, the less energy you're going to consume.
Yeah, as soon as you get any inductor into harmonic resonance, your
Because of
potential goes through the roof.
efficiency.
Yeah,
They sell these things called pure sine wave inverters.
yeah,
They take the sine wave from the grid,
yeah.
from your electric company, and the device will clean up that signal and save you 50% of power or more.
See, when you
Just by
like,
cleaning the wave up and getting rid of all the distortion that came along with it.
say Philips device, if you
Solar
had the power,
distortion, lunar distortion,
see,
earthquake
like,
distortion, you name it.
yeah, like if what Philip wants to do, that generator would have to be in space, because now you could take advantage of the absolute zero
Quality factor.
temperature,
You need a
right?
clean signal, a perfect signal.
Yeah, and I think I would need a capacitor as well, like a giant capacitor, because you would require time to accumulate energy. Because I
Well,
don't
that
think.
amount of power, you would warp space. Like with that amount of power going through a capacitor bank, like you're working in a whole new level of the heavy side component, and you're going to create such a massive field around it. Enough to make your hair stand even in outer space.
Yeah, but
You know what I mean?
that's the idea. The idea is to take all that energy and channel it in a one beam, one little beam. That's what's
Yeah.
gonna
Well,
create
yeah. A lot of people call that point source. So you need point source technology. So like the sun, like a perfect example. Take the sun's power, and you put it through a magnifying glass, and if you focus that beam on a piece of wood, and you focus that beam really, really tiny with the magnifying glass,
the.
that's point source technology, and now you're
That's
able to
he's
burn
talking
through.
about what HARP does. HARP is
But
creating a
he
signal
needs.
array that focuses the signal into
Well, that's point source.
clean.
Whenever you focus any kind of energy source to a small point, like he's saying, like focus it to a small point, that's point source technology is what he's after. So it'd be like lasers all focusing in on one point, right?
Yeah, but then I mean, at the end of the day, the beam would be straight. It wouldn't converge or diverge or anything like that. It would
Yep.
have to be a
Conical
straight
shaped
beam.
coil will
It'll be so focused. It'll be like, super symmetrical in a straight line, right?
Yeah.
cone shaped coil, Philippe. A cone
Do,
shaped coil. The tip of the cone is where you point the signal.
do you
So
know what's max, the maximum capacity of a capacitor?
Oh, the sky's the limit. You just keep adding on. Like I have like
yeah,
capacitors right now that are rated at 2,500 volts DC at 8 microfarad, and they're the big ones. The oil filled ones are like
Yeah.
canisters, right? But I've seen capacitors at the substation that they're the size of a car. So
Oh, yeah.
this,
Well,
the
obviously, you could add a bunch of
oh
them
yeah,
together.
hook them all up in series or
Yeah,
whatever.
yeah, exactly.
Multiply the power, right? Because the high voltage coming out of the mains from the power generation, you're looking at 200,000 volts, right? That's a lot of
Yeah,
freaking power going through a line. So
yeah.
yeah, yeah, you're talking super horsepower, Philip.
Yeah.
Super horsepower.
again, I don't think you need all that kind of amperage to do tractor beam stuff.
You
I
could
think
do
it's
anything with
sonar.
it.
I think it's sound tech.
Guys, I'm just
Sonar.
gonna head out for a quick smoke. You guys just carry on, and I'll be back in 5.
Okay. So
No, I
sorry,
say you
what
can
were
do
you
it with
saying,
sound
Mike?
waves. You can move stuff with just sound waves.
Sound waves?
Low frequency.
Oh yeah.
Low
Mm.
frequency sound waves can, bigger the object, the more affected it is by low frequency.
And that's gonna freeze
Yeah,
whatever's object
if
is
you're
doing
trying to
that.
tractor beam a small object, you need to make a frequency that is the same dimensions as the object.
Oh, you're talking about the resonance?
Well, I mean, if the object is 1 centimeter that you're trying to move around with frequency,
Yeah.
and you have to beam the frequency that's 1 centimeter size and target that 1 centimeter item with that 1 centimeter beam of frequency. And that's pretty much what I think is the case here. So if you have a low frequency and you want to move a building and the building is 100 feet tall and you have a frequency that's 100 feet tall and you can move the building with that frequency. If you have a frequency that's 101 foot tall, you're not in resonance with the 100-foot building. You're 1 foot out of resonance.
Yeah.
You see what I'm saying?
Yeah.
Even though your frequency is bigger than the building by 1 foot, it's still not exactly the size of the building.
But that's gonna if you put in if you reach the natural resonance point of the natural frequency of an object, I mean you're gonna break it apart. That's what's gonna happen. It's gonna blow up in pieces.
Yeah, like a glass when you reach the glass, a glass, a wine glass, reach the resonant frequency of a wine glass, it breaks
Yeah. Yeah. Exactly.
because it's going to vibrate at maximum vibration
Yeah.
because the sound wave is in tune with the glass and it can actually affect the glass at its maximum because the sound wave, when it's in resonance with the glass, in tune with the glass, meaning this wave is exactly the same height as the glass. That's probably the first part of the tuning. That's what I'm trying to get at.
Yeah.
Not so much the wave doesn't look like a glass. It's not shaped like a glass. It's just the same height as the glass.
Yeah.
So it does, it evenly passes over only the glass
Yeah.
and not more than just the glass or less than the glass.
Yeah, that's right. But if it's a different glass type of glass, then the resonance is going to be different.
Right. Depending on the material of the glass, then the frequency changes because it can be dense or more dense material, you know?
Yeah. But
Yeah.
if it's the same material but a different shape,
Then the frequency changes because the geometry changes. And
yeah,
the
yeah,
wave geometry has to change to
yeah,
match the geometry of the device, of the item.
yeah, exactly. Okay, just want to confirm.
And that's how I see it. You know, I don't, if you had a frequency that's just a little bit bigger than the guy you're trying to pick up on the ground, then that frequency is going to pick up the guy plus whatever else it's
Isn't that
radiating.
the you heard of the Havana syndrome?
The what syndrome?
The Havana syndrome. Some um, some people. Some people were kind of attacked by ultrasonic waves in Cuba. Um,
Oh, the Havana syndrome.
the Havana syndrome, yeah.
I have heard of that. Yeah, I think that was the
So it's
Navy.
something similar.
I think that was the Navy with their ultrasound submarines.
Well, Havana is the name of the city in Cuba where it happened.
Well, was it exactly? Sound? I don't know. I heard of it, but I don't know exactly what happened.
It's in Havana, Cuba. There were Democrats, uh, diplomats. Sorry, I'm a little bit drunk still. Diplomats. They were they went to Cuba, and when they were sleeping, they woke up with a headache,
Oh,
and
right, right.
apparently they got attacked by ultrasonic sound waves.
So yeah, okay, that could be the Navy
Yeah, they
because
got weapons like that.
the submarines.
Yeah, submarine, but applied to civilians on Earth.
All you need is a signal generator and an amplifier and a satellite dish above the water. And
Yeah,
especially if you're in the water's perfect for transmitting from.
yeah, but you just need the right frequency. You heard of
Yeah,
the
I mean, you know, that's a realm that, you know, I don't play with stuff like that. But yeah, you can
yeah,
definitely create problems with frequencies if you want, you know.
yeah. You heard of the Havana syndrome, Mike?
What's it called? Sorry.
Havana syndrome.
No,
Havana syndrome.
Havana. I've heard of it, but I don't know what it is.
No, it's a diplomat that got attacked by ultrasonic sound waves in Havana, Cuba.
Oh, yeah, I've heard about that. Yeah, I didn't really know too much about it. Yeah, the U.S. has been working on some ultrasonic technology, like point source, where it's a flat panel, and they could use it for like riot control and stuff like that. Set a certain frequency, and it'll actually make you want to throw up or really irritate your brain. And yeah, they used it from what I remember. They used it in the Gulf War. So this going back quite a few years, over 24 years ago.
Oh yeah,
Yeah,
interesting.
yeah, they've been working on that. Yeah, they deployed that a long time. Well, the military had it anyway. Yep.
Yeah,
If
So
you're really serious about moving stuff with frequencies, a cone-shaped coil. to a
Yeah,
tip.
Tesla was working on the cone-shaped coils.
And either, the wide side of the cone or the tip of the cone.
Yeah, Tesla was making some pretty interesting coils. I've seen some of them. They were shaped like tornado cones, right?
Right, because the coil's gonna create a shock wave
Yeah.
right out that geometry in the pulse frequency that you use or whatever.
Yeah. Now the other one he made was called a Utron. It's two cones basically attached together like this. And
Right.
It was called a Utron coil.
Tesla made that?
Yeah, that was Tesla's invention. Then the other guy, one of his workers that worked with him, what was his name? Carr. Joseph Carr. He was
Otis Carr.
Otis Carr. That's it. Otis Carr worked with Tesla and taught him about that coil design for anti-gravity. So he supposedly made, the ox cart. That's what his flying machine was made with, and it had those coils in it, the Utron coils.
The ox cart.
Yeah, it was called the ox cart.
The UFO they made was called the ox cart.
Yeah. And they had working models that did fly.
Yeah, they used two.
He got shut down.
They call it a double tetrahedron.
That's right.
Piece of aluminum, looked like a diamond.
Yeah, but they were coils.
Yeah, and the U coil, the U core with a coil was the tips of the U was touching the diamond tips.
Well, it was spinning.
The coil would energize.
Yeah.
Right, they would energize the coil around the arm of that U core.
Yeah.
To pulse the tips of the U, which was connected to the diamond part of the Utron.
Yeah.
And the Utron would spin through the eddy currents through the core.
Yeah, it created some other longitudinal field that allowed it to raise off the ground. But anyways,
well, I think it's just centrifugal force.
He was shut down by the government. They shut his ass down real fast.
He created a centrifugal UFO. Centrifugal UFO. He had 4 Utrons on or I think it was 4 poles of the UFO.
Yeah.
4 spinning Utrons, and 2 were spinning clockwise, and the other 2 were spinning counterclockwise or whatever.
I think the largest one he ever made was, don't quote me on this, 30 feet in diameter. That was the largest one they made. They made small ones, like tabletop versions. But the largest one I know of that he made was about 30 feet in diameter. So
it was spinning, using spinning mass to create the vehicle.
Yeah, there was some other longitudinal forces involved there. There was something else happening in it. The field.
Well, the Utron is a piece of mass that's spinning, and it has weight to it.
Well,
and it's in the 4 poles of the ship, and the key parts, for balance. Yeah. And it's creating centrifugal force on the 4 poles of the ship. You know what I'm saying?
Yeah.
So the vehicle is definitely a centrifugally driven spin force. That creates centrifugal forces on the hull,
right?
Which gives you your lift. It's not no mystery. It's not like a mystery.
I think you get any spinning mass.
Any spinning mass that reaches a certain speed will have less weight.
You get,
yes.
Yeah, and that's.
And if you keep spinning it faster, it goes beyond weight reduction.
Right, and that's
and
what
goes
Phillips
up. It lift. Right.
That's what Phillips demonstrated, and it does work. You just got to get it to a way bigger scale and spin that rotor up to 50 to 100,000 RPM, which is actually.
How do you even measure the gallium and even know what the RPMs is?
Like, I think it just boils down to how fast you can get it to spin. The more you can get it.
How would you measure gallium? It's a liquid. How would you measure those RPMs?
Well, you could. They are sonar meters, like it emits sound, and with the sound waves, you can, because it's a closed container,
You can translate from the sound,
so you
the
can measure
RPM.
with the reflection of the sound or the sonar, their devices for that. I look for it, but the problem is it's a circular device, so you need to make sure the sound goes in the right directions and things like that.
Yeah.
Or you put it upside down, like on top. You put the sonar on top, and you detect the deflection at the bottom.
Right.
You know
What
the
way
so
is
the
in what
depending on
direction it's
this,
going to deflect?
yeah, depending on the speed. Oh yeah, so sorry, it's like a V. It's like a V. I forgot. It's like a V. So you put like two, an emitter on top, a reflector at the bottom, and the detector a little bit farther on top, farther away on top, and you can measure the speed of the gallium
Yep.
based on the frequent the Doppler shift of the sound wave.
Mm.
That's how you measure this. You can measure the speed.
You suppose if you had a second uh, MHD on top of the first one, and the one's rotating one way and the other's rotating the other way.
Kind of rotation.
Well, that's gonna cancel the effect, I think.
Yeah, probably would.
Sure.
Or how about would it make it stable? Like, would it
Yeah,
help with
I'm not
stability?
sure honestly, because when I did test the vortex, I had the duration. I had the current going in the two opposite direction, and I got a weight gain in both cases. So it might just add up to they might just be adding up instead, because it's all about the energy density.
Mm.
I was a little bit confused if the energy density would cancel or would add up. You know, it's like if you mix paint. If you mix all color of paint, you're gonna get black. But if you mix all color of light, you're gonna get white. So I wasn't sure if it would add up or cancel out, but apparently it adds up. But I'm gonna confirm. There's a lot of things like that. I'm still confused. I got the effect right, but I don't have the duration right. I'm still a little bit confused on the duration.
Mm.
If I put it sideways, then I get a weight loss.
Yeah.
Sideways.
Yeah,
Like vertical, up and down.
yeah.
So you get weight loss on vertical.
When I had the grinder sideways with the horizontal normal of the disc,
Yeah.
then I had the weight loss.
Mm.
But everything else, I had the
Maybe
weight
if you
gain.
had two of them like this, you know.
Yeah, yes, exactly, something like that. That's what I want to know. I'm gonna work with University of Sherbrooke to narrow that down, but I need money first.
I mean,
And
like two of them like this, but one is going clockwise and the other one's going counter.
yeah, exactly, like a V. So I'm probably gonna get a serious weight loss in that case.
Yeah.
There's all kinds of things you could try out. It's just limitless, really.
Got to experiment,
Yeah,
experiment. Set up a rig where you could actually alter the degree
Centrifugal
angles.
experiments.
Yeah, you set up a rig so you can actually adjust your angles. Start at total vertical and just start working your way down, 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 and keep going.
yeah,
Start logging all the data, right?
It's still a gyroscopic effect, though. You know.
Sure.
So if you have it, once you start spinning it, no matter what your position is, let's say you hold a position like this, you start spinning, and then you try to move it. It's not so easy to move because it's already spinning and it's locked in its position. That's so weird.
Yeah, we got Lulu online.
Hi, Lulu.
Hey, Lulu.
She's your mic is off there, Lulu. You got to turn your mic on.
Is that
I
explainable?
thought that
Why it doesn't want to move after it's already being spun and it's locked in one position, the gyroscope? Does that make any sense? It's like gravity is keeping it in position.
yeah, I'm gonna have to. I'll need multiple apparatus to test that. So I'll need to buy a bunch of them and reproduce them. So it's already smelling like commercial stuff, like mass production of the apparatus. At least I got the apparatus Model One right, and it's not leaking or anything. Thanks to my lab technician associate Chris Reggie. He's um, he's a smart guy.
Chris Reggie.
Yeah, my assistant who helped me out with technical details.
Yep, that's always good to have. Lulu, your microphone is muted, so.
I am
See how
here.
the YouTube
Trying
Oh,
to
channel?
there
get
you are. There she
Yeah,
is.
no, I was trying to get settled. So I was listening. I was treating the kids, so it's just I don't know. I listening to you guys in the background. You were talking about the Havana syndrome. Was that a Marines thing, or I thought that was a weapon that came from satellites? Directed downwards. From up down to on Havana in Cuba.
But
I
I
think
don't know if ultrasounds can go from just satellite. It is in space, so ultrasound it's not going to work from space.
I thought it was called the lidar system. I think that
LiDAR is a depth perception camera.
is it. I think it. I know I read about a weapon that was, that could target people from satellites or areas, not just
Yeah,
people.
lasers can, so you can blast anybody
Yeah,
with a laser coming out from a satellite.
yeah.
Yeah,
But for ultrasound, you
yeah,
need
it's
to
got to
be
go through
on
the
the ground.
atmosphere. Yeah, it's too much distance, and you got to go through the atmosphere. It's just it's
Yeah,
too much. But a point source technology like a laser can do that easily.
Yeah.
yeah.
I know there's ones that earthquake, like they drill holes in Antarctica and they put these rods
Yeah,
in there and they blast high voltage, which they start radiating, but that causes like a shake in the ground where at another part in Earth it could cause catastrophic devastation. And I think it maybe like 6 7 months ago they turned on that machine to test it out, but it hit a church somewhere around the world. Like a massive earthquake happened in that area and it collapsed, and there usually is not, there's no earthquakes in that area. And everybody was saying, oh, it's the new weapon, they were trying testing it out. And so yeah.
Yeah, they got all these classified weapons they're testing once in a while.
I mean, they say classified, but it's all over the scientific, discoveries of new things. It's everywhere. It's like people don't put 1 + 1 to equal 2. They don't connect the latest to things that are coming out to what is happening on land. You know what I mean? They don't connect the two things. So people that I think read a lot on the stuff kind of understand that, oh, this is connected to that.
yeah. So
Very, very interesting topics. I'm gonna
You
mute
can
myself.
also take light, um, a laser pulses and make sound.
Yeah.
Oh, I got a new book I want to show you guys. Hold on one sec. I'll be right back.
Like they could use lasers to create sound, like from like in space. They could beam a laser in your backyard to make your backyard play a concert.
Bring it over.
That's what I'm trying to say. The ground in your yard could become the speaker just through the pulses of the light.
Nice. It's like one of those inventions, the alien scientists in the Falcon Lab, they call it the voice of God. I think one of them invented something that like could literally, if they beam longitude, latitude, I don't know the exact method they do, but they could like, you could hear voices, you know, if they want to target somebody. It's called the voice of God, which is kind of very interesting, you know?
Yeah, that
And
book
they
I got.
create focal points with these
What is the book called?
frequencies.
It is called Homemade Lightning. It's by R.A. Ford. It's third edition. It shows you how to make the electrostatic generators, like the Wimhurst machine, Van de Graaff generator, a whole bunch of stuff. And it gives you instructions and plans and everything how to make the devices. It's a like 350-page book, and it's got some really good illustrations and a whole bunch of different types of Wimhurst machines. Yeah, so I'm going to be going through some of this stuff. Oh, geez, we got a problem here. Oh man, hold on. Might have to start the live stream again. You guys still with me?
Yes,
Yeah.
sir.
Yeah.
Something happened. I had this problem earlier tonight. That really sucks. Let's try this. Oh no, it's still going. I think everybody's reconnecting. I don't know. StreamYard's been glitching on me tonight. Before I went on, when I was starting everything up, I was getting some glitches, and it just did it again. All right, it looks like I think we're back online. Anybody in the chat, can you please confirm we're online and we're running?
What's up, Anthony?
Yeah, I saw some comments from people online earlier.
Yeah. I just want to know if we're back online now. I'll probably just check them. You guys continue to talk. I'll just try logging. Yeah, Anthony says we're online. Okay, so we're back on. That's good. All right, yeah, so it's a really good book. My buddy there that got me the barium titanate. I've been showing everybody. I got the barium titanate for the batteries I'm going to be working on. So got me the book, and I'll be going through some of the stuff in this. Might give me some ideas. So yeah, starting to build my book collection now. And a lot of the stuff I find in books, you'll never see it online. Like some of the stuff that you can find, just got to know where to look. Yeah, there's some really good stuff out there.
I would be a reader if I could stay awake.
You're ahead of us,
sleep
right?
when I read.
Like I'm Central Time. You're.
I'm Eastern.
Eastern.
I'm Eastern. Yeah, it's 10:34 here.
Here it's 9:34.
Yeah, so we're an hour ahead. Yeah.
I passed, like news with me. I passed an exam, and I'm going to be a licensed insurance agent in the state of Texas.
There you go.
That's
Congratulations.
Thank you. I'm so excited, that I passed this test. I've been like studying for the past month and a half for it.
That's good.
Yes.
So you're gonna put people in jail, is that it?
No. Actually, like provide healthcare or life insurance.
Oh yeah.
Yeah. So no, it's the other way around. saving people.
Yeah. Yeah. Well, what's up with Gerald? I thought he had something to present this week.
Yeah, I don't know. He gets caught up in stuff, so he's busy at home. I think he has his own business or something in catering or whatever.
Yeah.
Who's that?
Gerald.
The one with the Graviflyer, the one that's building that.
Virtual, remember? They remember these hover coil. Sorry,
Yes,
Yeah, the
yes.
coils. Yep. Yep. The coil man.
Mr. Coil.
Mr. Coil.
I so want to see that thing fly. He talks about it and everything, but I want to actually see it.
I've seen it. I've seen it go once. He
What?
did it offline.
Okay. I want to see it in one of those presentations other than just pointing to it. Like, okay, turn it on. Like
Yeah.
turn it on. Not
That
that I'm
guy,
being,
old
not that
man
I'm being
Bill's, his
skeptic.
channels, he's getting close.
Not that I'm being a skeptic, but I really want to see it. Like I really want to see it work.
Yeah, I passed 3,000 subscribers this week. Kind of a milestone for me.
Congratulations.
I know,
Yeah,
right?
yeah, over 3,000 now. And I got over 430 videos on my channel.
You're getting
Yeah,
famous. Watch out, the deep state
no,
is gonna, the deep
no,
state is
that
gonna be watching
I've
you.
I've been already shadow banned already.
When that happened?
Oh, a few months ago, at least last year, it happened. I was
What
getting a
was the
lot.
trigger?
Probably the renegade stuff, getting the over Unity stuff.
How
Yeah,
you know you got shadow banned?
because my the amount of traffic I was getting to my site just like dive bombed.
I
Yeah.
figured a way around that. Yeah. So this is what I did with the Alien Scientist channel. I went to Verizon to one of their stores, and you know how they have those little devices sitting out, and like you could search whatever you want just as a test, like the iPads, iPhones.
Right,
So I was waiting in line. I was bored, so I went on their iPads and I put in their search query the Alien Scientist. Well, what happens is they have a database that collects that information, and
right.
it's like their server is much more powerful than the server that they spend money on it. And
Yeah,
I put his
Huh.
channel on there now. Like all of Verizon has that, so they can't shadow ban him because that means somebody will tap into their servers for that data.
right.
Like
Oh.
yeah. So I did it the other
Hmm.
way around, where you go and expose the channel like in a good way, like publicly, where now it's in their algorithm. They can't anymore, like take it out.
Oh,
So yeah.
do it to my channel.
Yeah, that I promise you. Next time I go, I'll go to the, and I'll put the, the Faraday. Um, yeah, I think you'll see. You'll have a lot more followers after I do that.
Right on.
Yeah,
Cool. I'm up
yeah,
for that.
yeah. I mean, this is just ways of kind of going around the system. Even if you go to a public library, it depends on where you search the channel, because they can ping individuals, but when it's a
Right,
company, it's kind of hard, to control
right,
that one.
right.
Yeah.
So as soon as you ping using like a company's computer,
Hmm.
it's now altered the algorithm.
Yes, it'll also, because
Really?
it's not anymore from an individual IP address. Now it's like in the corporate server. Like
Oh, yeah, yeah, yeah. Okay.
it's like
It's in their private servers.
it's using their system.
Right.
Yeah.
Yeah, because mine's running, I believe, off the Cogeco network. Like it's a third-party company I'm with.
Yeah.
So I'm running through the Cogeco network. So
Yeah.
yeah,
Yeah, but when you use a telecommunication network, you can't stop it. Like
right.
it's like planting a seed in their midst, rather
So
than
if
I
so
can.
if I go so if I go to the public library and type it in,
Yes,
it'll
like
it'll change it.
it will. You will get a lot more exposure. But really,
Really? Eh?
go more than
So
a
what
lot.
do I have to do? Just log in? Just log
Just
into
go
the
on their Google or their YouTube and search yourself. That's all, and play a little bit of the video. Maybe put a comment if you want. Just so it yeah.
Okay. Right. Okay, I'll have to keep that in mind.
No, but I promise you, next time I go, like, because I go to pay my bill like in person. I don't like
Right.
doing the full third party
Right.
thing. Yeah, but next time I go, I'll wait in line, and you'll be the next person I search how it goes into the system.
Cool.
Yeah.
Yeah, so do an experiment, see if it actually does it. Yeah.
I think I saw, like, on the alien scientist thing, he jumped like maybe 20, 30,000 in like 2 days after I did that. So
Really, eh?
yeah, I don't know.
Wow, that's weird. Never heard of that one.
It's just how the information is being
Channeled.
Yes, it's a, and what systems are you using? Private, public?
Now, say if I were to take my laptop and connect to the public library's Wi-Fi.
No, use the computer in the library that's already on the
Oh,
network, not
right.
yours. Yeah.
Okay.
Yeah.
All right.
Just something.
So I missed
Yeah.
the part. Well, why would you have more viewers by using the public library?
Because it's
Because
an open system.
those computers are like, they log everything, so they know what they sell your information to, sell you products that you like.
Yeah.
So if you search
Oh
for
yeah,
like
the
socks or
targeted
whatever,
marketing.
yeah. So
Yeah.
like a public computer, you go on their browser, like an internet cafe or whatever, all those those internet cafes are going to sell the information that people that use those computers to, type stuff in, like ice cream, whatever,
Right.
Yeah.
They know how to market.
Oh,
Like,
okay. So yeah. So now you're gonna be like an ice cream seller, Mike.
you have AI
Ice
making
cream.
all the key logs of
You get
keywords.
more exposure to searchers because now your website or your site, your YouTube channel is logged into their categorization system.
Yeah.
And
Right.
But you would need to go to multiple libraries and log in to all of them. So
Or just
to
go to one
maximize.
library that's got multiple networks.
How about just like companies, their internet connections through a company?
I can
That's
create
what I'm telling you. Like a telecommunications company, AT&T, Verizon, T-Mobile,
Yep.
even the Apple Store. If you go into the Apple Store, you could do that because
Right.
they have much more clientele. Like they have a smarter AI system that could, categorize the type of information you're teaching and expose it to more viewers.
Right.
As
So what I should do is go to my local mall where they have, Virgin, Cogeco, whatever, Bell, and then go to all those stores and then log into my website through their computers
log it in or just search it.
or
That's
search it.
slower.
Yeah, search
Yeah,
it.
I
Yeah.
wouldn't even do that. They get your password. Gee, log in.
that's what I'm saying. Don't
No,
log in,
no, no,
but
no, not
search
log
yourself.
in, but just
I
search
mean,
my
you can log
my.
in as long as you see the little rock on the top there.
No, I wouldn't log in there. No,
But
but just
it logs it in. Your
You can
like
log in if it's encrypted.
yeah, I would just go to the
That
major
doesn't mean
cell
they're
phone
not key
companies
logging.
yeah,
because I
no,
know.
do not log in. They will
No,
get your password and
yeah,
information. If you
yeah,
search only, it will log it in as a search query, where
right, yeah,
it categorizes it as a scientific channel. And when people search for any keywords that you have spoken on this channel, it
yeah.
will populate, like the search query will pick up those words, and you would come on that, that stack, like number one, number two. It just depends on the percentage of how
Oh,
prevalent the search goes to.
I have a question for you, Lulu. You heard of that a website called Academia?
I think I heard, but I've never been on it.
Right. Well,
Academia.edu.
yeah. So what's happened is a lot of stuff I'm talking about is starting to show up on Academia,
It's good.
and like I'm actually getting mentioned in experiment notes and review notes and stuff like that. I was just wondering, like, the membership I think is like $1 a month or something like that, and you could see who's talking about you and your work
Mm,
through Academia. So, and the
Interesting.
last one I got, they were actually talking about my battery cells, my polymer battery cell. So, I kind of want to check that out.
Yeah, I mean, if like you could have access where you can input more information, that's wonderful.
Yeah.
Yeah, and ResearchGate also .net.
Yeah,
Yeah, it's similar. It's similar to that. Yeah, it's called
Yeah.
academia.
Yeah.
See, what helped my searches is because my when it comes up on my name in the search, it's Mike K. Faraday, like Michael Faraday,
mm,
Michael Faraday, the inventor, right?
You know,
So
that the word Faraday might be helping, but it also could be, harming because you can't get your exposure. You're getting Faraday exposure.
well, actually, it could actually be getting me traffic to my site too. You never know, right?
That too, right? At the same time, but people think they're looking for Michael Faraday, not you.
Yeah.
They're
Yeah.
looking for the Michael Faraday, the guy who,
Well, they
whatever.
start seeing. Well, they start seeing my experiments, and they'll
Isn't that
go,
the
"Hey,
Apple
yeah,
guy? Or that's Newton, sorry.
yeah, that's
You
Isaac
can see
Newton."
my level of education right there.
Yeah,
I'm very rusty with all the physics.
yeah.
Newton is the Apple guy. Faraday is the coil
Coil guy, yeah. Induction,
induction.
magnetic,
Right.
first generator, first electric motor,
But
first.
for Faraday, I think was it him that he liked education and Maxwell took on his work.
Yeah,
Uh,
yeah. Everything that Faraday did in experiments, Maxwell made the mathematical equations for
yeah, yeah,
it, based on his stuff. Yeah.
yeah. I think a lot more happened before the Nobel Prize. I think the Nobel Prize for me. Did you guys know? By the way, Nobel Prize was our friend Nobel was working on bombs. He was creating bombs for the military back then.
Liquid
Yeah,
nitrogen.
yeah, and TNT and all that. And he took his fortune and he created the Nobel Prize. But I think the Nobel Prize kind of turned the scientific community greedy, and now everybody wants
Yeah.
to um, to be like Einstein and Stephen Hawkins and all these people, and it's like they won't listen to anybody, to people outside of the academy, outside of the mainstream, like against them, people against the mainstream or things like that. They kind of use our tax dollars to give themselves prices, you know what I mean?
Right.
So I don't think it helps. I don't think it helps the advancement of research and
What, the Nobel Prize thing? Hmm.
specifically in astrophysics, because there's too much politics and things like that. It depends. It's all about who you know and who you are and things like that. And if
Well,
you're
that's where the freedom of enterprise, comes in. When you have free enterprise, you have freedom of everything else. Science, open researches, open source researches. These companies that are like, making products, they're not open source, they're
yeah,
trying to make money.
yeah,
So off of the product that they're going to sell to everybody, but
yeah.
that
So that's
doesn't
why I
leave
kind
room
of
for advancement at all. That's just the opposite.
yeah. That's why I kind of I am in. I started my company is because I saw that getting the Nobel Prize and things like that was impossible for somebody outside of the academia and things like that. So I said the hell with that. So try to make money out of it instead.
I mean, if you just publish your research in a way that it's understood by the layman, it'll get out there. Someone will pick it up. It'll be picked up by someone eventually that it needs to pick it up. And
Yeah, I hired
res-
a PhD to rewrite my manuscript, anyways. Like in
if
the
you
correct
don't open
language.
source your stuff, then nobody will know what you're working on,
Yeah,
and you can't get any input on it. I
yeah,
mean, the only way to get input on something is for others to know exactly what's going on. and then they can contribute to what they think is going on, you know?
Mhm.
Yeah, when it comes to energy devices and just devices in general that use energy, even if they're not energy devices, they're still being discovered, you know?
Yeah.
All this is open, you know, new territory, even though Tesla broke the ice on a lot of it, it's still, a lot of it's undiscovered territory.
That's why it's kind of good to go back and try to source out like old books like this, and you know, I find you're getting way better information from old books that were, made, say, published back in the 1920s or turn of the century, right? You can get a lot of stuff in here that you will not find online because they don't.
People
It's
were extremely smart. They were not blinded by Einstein and all these by trying to be smarter than Einstein and all that crap. You know what I mean? They even the electrons. They were at some point. I postulated that an electron. Um, what is it again? The electron could be massless, but somebody already thought about that in the early 20th century. It's like everything you can imagine. Everybody already thought about it, so they were very ingenious at the earliest 20th century. I think that's amazing. And after that, they kind of academia became kind of well in astrophysics, not in computer science, but in astrophysics, it became kind of some political nonsense,
mm,
and like
Let's
the
be real, when Einstein was running around, you know, with E equals MC square and, you know, G are, um, there was at least 1,000 other Einsteins just like him and living on Earth doing the same thing he was doing, if not better. They
yeah
just weren't discovered. They were undiscovered. That's it.
there
You know,
were
they pick one guy to they don't want a bunch of scientists figuring everything out.
yeah
They want people fighting with each other all the time, not knowing what to do. You know, if you have a bunch of scientists figuring everything out, then there's no more problems.
yeah. No more problem means no more deficit. No more deficit means no more profit to the
yeah,
central banks.
And look what
yeah,
the one scientist that they gave the limelight to, and the other thousands of scientists were just disregarded in his time.
oh yeah,
You don't know who they are because they're not there because they didn't put
Yeah,
them there for you to
and
know who they are.
who
You know Einstein.
do
So,
you
but that
do
one
you
scientist, look what he did.
yeah
Look how many problems he solved, and look how many
do
problems he may have created.
do you
I don't
guys know who Henri Poincaré is?
know.
Do you know who that guy is? Henri Poincaré. Do you know who he is? He's the
No.
guy who actually invented E equals MC squared.
Oh, okay. Yeah.
yeah,
He
yeah,
invented the term relativity. He also calculated the gravitational waves, and he also calculated some way of predicting the stock market. The guy
Right.
was a true genius, and
Right. And he
he's
was
he,
probably a genius who was going around the world meeting with other geniuses who were all on the same page as him.
yeah,
But none of
exactly,
them are known today. Only Einstein.
yeah.
I thought Einstein, like E equals MC
Or
squared.
no, he didn't.
No,
Yeah,
he
so Einstein
was a
was the one
patent
of the,
clerk. He was behind all those great
yeah,
discoveries.
yeah. Einstein was the biggest plagiarist on the planet, and there's a couple of guys out there that did a show on him and told about his real life story. Um, Most of his writings were all done by his wife, not him.
yeah, yeah,
You're talking about a
And
time when there wasn't social media. The media was
right,
completely controlled.
right.
yeah.
Now they
But
have, social media.
apparently his wife was the one who actually wrote the paper for the theory of relativity when he actually presented it.
Yeah,
That was his wife's work, not
but
Right.
his.
back then, even nowadays,
Right, I heard that.
the astrophysics industry they reject women.
Yeah, yeah,
They couldn't win the Nobel Prize.
that's right. That's why she gave it to her husband
Yeah,
to be the front man.
yeah, exactly.
She was more of a genius than he was.
Man, we
Yeah,
still though
exactly.
live in those times. It's a patriarchal society, not a matriarchal society, and it's still like this today.
It's still like that.
Yeah.
In Sabine Osenfeld, the girl I keep posting, the girl, the woman who's a PhD in astrophysics, she has a YouTube channel. She said it herself. She had to become she had to become to start her own business because she kept being rejected by the academia just
Yeah,
because she's a woman.
I
yeah,
like Sabine. I love her videos. They're really like they're interesting to watch. Like you actually understand a lot of concepts when she explains them.
Yeah,
I think she's a very good physicist. Yeah.
she's explains it in layman's terms, especially quantum physics. It's really simple. The only thing difficult about physics is they always use these weird symbols or these Greek letters and so on. But it's the same calculus, differential calculus. It's all
yeah,
the same. There's nothing hard in or linear algebra and so on. It's
yeah,
all the same. They just use fancy symbols.
yeah,
But
yep. That's
yeah, but yeah, that's
Well,
yeah.
I know what
Einstein,
epsilon is. Epsilon is I looked it up. Epsilon is the permeability of something.
the
yeah. I always got lost with those
epsilon
symbols.
naught. It's the permeability of
How
electricity.
much
The
how much
permittivity.
charge can the thing take? That's the permeability.
The
Yeah,
permittivity.
The,
Electron charge.
the other
Yeah.
day I was watching a video. Like I did not know this. Like for example, hydrogen holds three different states. Like three different frequencies, and it's still hydrogen. And so that was kind of
Huh.
interesting.
Oh yeah.
Yeah, like I did not know hydrogen could be like in three different oscillating states. Yeah, and
You just
Huh.
remind me of something. I'm gonna share my screen here. Just
well,
one
it's a
second.
well, hydrogen's a very large component of what water is, right? So
yeah, yeah, no, but we're saying hydrogen on its own, not bonded with any other element. It could
yeah,
hold different three oscillation
sure,
states.
sure.
Yeah,
Even water does that on its own.
yeah.
Or the hydrogen in the water.
Yeah, well, water as a whole, as an H2O, right? But
Yeah, put on my screen, Mike.
okay, what do we got here?
Can you see that? Can you guys see that?
Yep.
Yeah. So at the top it's a photon, at the bottom it's an electron. Electron is the same thing as a photon. It's just that it's it, it has a self self equilibrium, so it's not moving. But it's the same thing because a photon it can be, with the pair production can split into an electron and a positron. So it's just the it's not like people picture the electron like a pool ball, you know, a pool ball that rotates around a proton and so on. But it's not the case at all. It's actually something like we see at the bottom of the screen, something like that, some electric and magnetic field rotating around themselves.
Yeah.
And
See,
it creates,
I personally still think the electron is part of the heavy side component. I kind of agree with Tesla when he talks about the electron. He was dead set against the electron theory.
And what was this
The
theory?
electron is now, let's get this again. The electron, because they keep changing it, you know. First,
It's
they said
part.
the electron, it can be in all places at all times. It just reappears and disappears and reappears and disappears and reappears, bouncing around so fast that you don't even see it moving. It's just at all places at all times.
Superposition.
But now it's got mass all of a sudden. And then Philip says, well, electron can also be massless. How is something that has mass supposed to be in all places at all times?
Well, that's the thing.
In
That's the
theory,
thing.
energy can do that.
That's another thing that is very confusing. But hear me very for 1 second. It's very important because Einstein was saying light has no mass, but energy is mass. So it's
That's right.
paradoxical right there.
Right.
So
Right, but
Exactly.
that's what I'm saying. How can something,
I don't think
I
a
can't
light
even
is
say it really,
massless.
but you know, you
I don't
explain the
believe light
point.
is massless. I think
yeah,
light has mass.
so light is mass because it's
Yes,
energy. So it's the same
it's
thing.
it's energy in motion.
That's what I'm saying in my paper. I'm saying you can calculate the momentum of light and all that by considering light as a mass and
Yeah,
everything. I get all the right results. I got everything right, but and I'm skipping Einstein's nonsense.
yeah. Like
See,
I
I have something to throw into there. Light, yes, some spectrums of light, maybe most spectrums of light have mass, but you can guarantee yourself there is a spectrum of light that does not have mass.
yeah. But I don't believe that either. I think it's at a such a small denomination. We don't have instruments that can actually physically detect it. I think any kind of energy in motion has mass. Period.
I mean, you can't, just because you can't see it doesn't mean it's not light.
That's right. There's a lot of spectrums of photons that are not visible to the human eye, right? And even some of our most powerful instruments to detect all those different infrared and X-ray. The fact of the matter is that energy is in motion.
Because I heard once, I think it was the Electric Universe or Thunderbolt
Yeah,
Project.
yeah,
They said when the magnetic field curves in on itself, that's when the light is formed.
yeah. I'm
And
not
that
an
makes
expert
perfect
on that
sense
one.
because when the magnetic field curves in on itself, it self amplifies because it's curving in on itself. It's
Yeah,
like
I
a
still.
wave in the ocean hitting itself.
Yeah, but you know what? The only thing I could see actually, you know, categorizing as a photon energy,
The cat
it
chasing
would
its
have
own
to
tail.
be it would have to be some form of heavy side component, the electrostatic, at a very, very small denomination. So there has to be mass. Any kind of energy in motion has mass.
Isn't
But
energy
Motion does not
motion
have
like
hold on.
a
The motion does not have mass. Motion itself, the motion is
right,
massless.
right. But what makes
But
that
what is being
photon?
carried by the motion is the mass.
That's right.
but
It
it's an
has.
But the motion itself does
excited
not
state.
have
That's
mass.
why it becomes it has mass. Like,
For anything
but
to
Not
be
the
in
motion
motion.
itself. The mass is being carried by the motion.
For anything to be in motion, there has to be
Motion is
mass.
just a signal. It's just a signal. Or the mass is being carried by the signal. The
Well,
light, I don't know if that's mass or if it's just the magnetic
well,
field
it's a
hitting
yeah,
itself. A clash of its own energy or whatever. I don't know. The light is
yeah,
the magnetic field it curves in on itself. Essentially, it's hitting itself.
yeah. But one quote that Eric Dollard said, and it kind of really resonated with me.
That
He
makes a lot of
says,
sense to me, though. I'm just saying.
Eric Dollard says, if you cannot understand what counter space is, you will never understand what energy is. You have
Well,
to
energy
understand.
could be just that thing, that motion that was created, even though it's massless. It's still a signal.
Right.
A
But
signal is the motion.
like
The
for
mass is
anything,
carried by the signal. The
yeah, but
matter is created by the mass.
yeah, there
That's
has to
just
be
my opinion.
mass. There has to be mass
Isn't
because
motion created
First,
by
there's
the
energy,
electron
which is
exchange?
massless, but then there's mass.
the energy has to basically deflect the mass or push it through a median like the dielectric or the counter space like
Right. So the
Dollar talks
energy is
about.
the motion.
Energy is the motion, but there has to be something there. Like it can't be nothing. It has to be something.
Why not?
But then you wouldn't be able to tell there was any motion because if there's no mass, no something physical, actually something
So what
physical.
you're saying is for the radio wave to get from point A to point B, there has to be mass in the middle.
Well, all that a signal is, it's a perturbation against the dielectric constant or the ether. It's a pressure.
Being the air, which
The
has mass.
well, counter space. It's a deflection of counter space.
Massless counter space or mass counter
No,
space?
no, like you're talking about a signal, an actual signal, right? So there's still energy involved, but it's a deflection through counter space or open space that pushes that signal through. Well, people call it waves, and Dollard says that's not a right terminology for it. It is a
I
deflection
think it's a
of
signal, not some. You could wave. It could be any shape. It's a signal. It's a motion.
energy. There's still energy involved.
So the mass came before the motion, is what you're saying.
There had to have been.
Okay.
Because if there's no mass, how do you move something if there's no mass? If it doesn't exist, how can you push something that doesn't exist?
Entropy or implosion.
Well, there has to be
Implosion.
there has to be something that's imploding. So is it counter space? Is it the dielectric?
Well,
Is
does there really have to be an explosion for there to be an implosion?
well, what's going to happen is the counter space, say it's gravitating towards the center, like say it's imploding.
Well, because
That
an
means
implosive force has got no explosive factor to it.
it's falling in on itself because there's nothing there. So that means the
Right, so
dielectric.
an implosive force does not require an explosive force to exist, is what I'm saying.
Like the
There is no explosive factor in an implosive reaction. There doesn't have to be anyway. There does not have to.
Well, that's when you get into the dark energy. So on an implosion, is there dark energy involved where it creates that negative collapse, right? Yeah, we're getting into real like heavy duty like physics here.
We are familiar with the explosion, the outward force.
Right. But there's always matter. Like say like a bomb, right? So when they build a bomb.
But did you have to do anything to breathe in the implosive force?
No, you just got to remove the counter space from the equation so there's a void and then it just collapses in on itself like a black hole, right? It absorbs light.
To breathe in your implosive reaction, you're doing that by removing energy, not adding energy.
Like you're creating, like say, like an example of a black hole, you've got basically a huge magnetic field around the rim of the black hole, but inside in the middle, there's nothing there, to the point where there's so much of nothing there that it basically attracts light. That's how powerful it is. It attracts gravity, everything. But you're talking something that is so ginormous in size.
Or better yet, the black hole is so forceful that it causes the magnetic field to bend in on itself and thereby creating the light.
I think, well, it's a collapsing star, right? So when you have that much amount of energy collapsing in on itself, you have an implosive, effect.
It would cause any magnetic field around the area to curve on itself too.
It will
Oh, well,
cancel out. It will go into counter space. See, when Eric Dollard he got
So
two
in
Tesla.
theory, a black hole would be creating light that wasn't there to begin with. It would take magnetic fields around itself, causing them all to curve in on each other, thereby creating light.
Yeah,
A black hole, meaning a black hole is going to then it's going to cause all the magnetic fields around it to curve in on themselves,
right,
creating light.
right. And nothing can escape it, not even the
That would
photons.
explain why the light's being so visible around the edge of the black hole.
Yeah, well, that's exactly what it is. Yeah.
Right, to go back to the search engine, the targeted marketing thing.
Mm.
If I was to, because I did that in the past using Linux, I was accessing like 50 VPN server at the same time to access my own server. But if I would log in to YouTube or do Google search of Mike Faraday using 50 VPN server, would that propagate? Would that
I mean, it
propagate
would
the?
propagate. It would propagate Michael Faraday, the guy who with the coil, the induction coil.
Just go
Uh,
Faraday research on YouTube. That's all you type in. Go
okay,
in
but
the
if
yeah,
I do
Yeah, you
that
need
on
the word
YouTube,
research in there.
Mike
yeah. Put
Faraday research.
no, just do Faraday research YouTube, and then it'll
Okay,
go to my channel. Yeah.
but then that's gonna help the YouTube search algorithm to maximize Mike Faraday from being on top of the list.
I believe so.
Yeah.
Yeah.
Okay, so we could do that from home. Then I could give you my algorithm, and you can try it out, Mike.
I have no idea how to do that stuff. I'm not a computer tech. I,
Yeah, but
I know the basic stuff, but when it gets into that stuff, yeah, I'm not. But it'd be interesting to see if it actually helps my traffic flow.
yeah, I mean, I need to resurrect my algorithm. It's a 10 years old
Yeah,
algorithm.
Gerald needs help too. He got pretty much shadow banned there.
Oh yeah,
His channel's been
Oh,
shadow banned.
really?
Yeah,
he
big
he
time.
he, he talked trash
No wonder
against
I'm not
people or
seeing his.
something.
Is he posting videos?
Yeah, he's got a few bit of videos up there. He did one.
I'm not getting the bell notifications,
Yeah, you have to
and I'm
click on
so
his. Yeah, you got to
I'm
click on
subscribed
subscribe.
and bell to his channel forever, and they stopped coming in. And you're
Yeah,
telling me now he
that's
was getting shadow banned.
yeah. He's been shadow banned for a while now.
No wonder I'm not getting the bell notification.
Yeah, you got to click on his channel.
He's got a weird name to remember there. It's like
Yeah,
It's the same thing with
WWRD.
me. I mean, at some point, I had like almost 1,000 views for one of my grinder videos, and afterwards, when I started doing videos for the MSG Vortex, the more important MSG Vortex, I had like 50 views or something like that.
That's crazy. I switched over to Rumble for a little bit, then went back to YouTube.
Yeah,
Rumble's
Rumble is good, but all the videos are on YouTube,
right. Everybody's also
unfortunately.
using YouTube.
Yeah, it's
Rumble's
all
kind
about
of
money,
slow.
man. It's all about the money.
What do you need? Like a certain number of subscribers, and you like what is this? They monetize your channel or something? And
well, see,
what is
in the
that?
beginning when I first started out, I was getting like huge hits. I was getting 300-400 views within the first 24 hours, stuff like that. Now it's like I struggle just to get 200 views. But I did start posting on the Facebook groups So I've been getting a little bit better traffic there from outside sources. So that's helped out a bit. So
I'm waiting for them to come out with a blockchain service that integrates your one social media account with all of them, so you don't have to go through all that mess. You know?
Yeah.
And Google kind of did that, right? You can just log in with your Google account everywhere.
Twitter is not that bad either. You should broadcast on Twitter, maybe. It's not like politically. Twitter is not politically corrupted anymore since.
Yeah, I have to get the full version of the StreamYard to post on Twitter.
Okay.
Let's see, I just want to check here if Gerald's channel. Unless they yanked him off. Where the heck's his channel?
So, Mike, why am I getting 4.5 volts on the pickup coil from ground to ground and positive on the meter? Why is it to ground?
Well, you're probably pulling some energy from the ground. It's possible that you're getting some of the residual power coming from the ground. Because,
well,
like,
the meter's reading it from ground to the one terminal of the pickup coil. The other terminal's just in the air. I don't get it.
Where the heck? I can't find Gerald's channel. Did they yank his channel?
He probably talked trash against
He's
Trudeau.
got. How do you spell his handle? I mean, it's like.
Well, that's the thing. I got him in my my subscriptions, but I'm going through the list and I don't see his freaking channel. He might have got yanked. I'll have to find out. Yeah, his channel's not here.
Here. That's his handle. I saved it because it's so hard to remember.
Well, I have it in my favorites, his channel, but it's not coming up. And I know if your channel gets yanked, it won't show up in your subscriptions. What the frick is it?
Sorry. That's his email.
I know his email, but I'm talking about his YouTube.
But his email is the same as his handle. It's
they might have yanked his
WPGEN Lighten for real.
Yeah, his channel might have been yanked.
How are they going to yank your channel?
Oh, they did it to Bernie 3 times.
Oh yeah.
To Bernie?
Oh yeah. Oh yeah. He got
for what? Making Ormus?
Violations. Somebody started posting porn on his chat board during a show, and they yanked him.
Oh. You mean the StreamYard
no,
spammers?
YouTube. No, YouTube did that to him.
I mean, you know, when you go on StreamYard, sometimes these people get in there and spam porn or whatever.
Well, no, because it was broadcasting off his YouTube channel. Then
and YouTube, he didn't delete it in time?
Yeah, and YouTube flagged it right away and yanked him.
Yeah, you gotta delete that.
Yeah, I can't see Gerald's freaking channel listed here. It's gone.
Yeah, I can't find him.
Let me see if I can.
Yeah, I think his channel got yanked this week because I logged into it last week.
Wow.
I'll have to send Gerald an email after the show.
Did he use anything that was copyrighted?
No, he doesn't have enough on his channel to really worry about that.
Why would they yank his channel?
Because of the stuff he's working on.
Oh, he's being silenced?
Yep. Shadow banned.
Oh, there.
Yep, his channel's not in my listing anymore. It got pulled off.
Hey, let's keep in touch next week. I'll let you know.
I'll send Gerald an email this week and see what happened with his channel, and hopefully he could come on next week and let us know what's going on. Yeah, because his channel's not listed anymore.
Oh, I found his channel.
Because
it's not coming up on mine.
At the same time, I'll let you know if
must be an older channel of his.
I'll let you know if they're trying to silence me after my presentation on Tuesday.
Exactly. See if I can log into it.
You see it in the chat there?
Yeah. It says I'm not subscribed. What the heck?
Yeah, that's what it said to me too. I think this might be another channel that he made.
Oh yeah, this is new. I think his other channel got yanked. Okay, I'm going to subscribe to that. Yep. Yeah, he got yanked. So he opened up, it looks like he opened up a new channel because For Truth wasn't there before, as far as I know.
No, he's fighting back even harder with
Yeah.
For Truth.
Yeah, because he's only got 232 subscribers. He had more than that before.
Okay.
He's not using any iron in his cores, huh?
Doesn't look like it.
Or air core. All of his stuff is air.
Anyways, guys, it's 11:20. I think we're going to call it a night. Thanks everybody for joining me tonight on the panel, and everybody in the chat room. Thanks a lot for posting your comments. We'll go live again next Friday at 9 o'clock Eastern. Everybody have a great week, and yeah, we'll see everybody soon.
Take it easy, and don't forget to check out the Telegram channel also.
Yeah, we'll do.
All right.
Okay, take care, guys.
Later.
And ladies.